In this video, we are going to find limits algebraically. And so in this particular case, when you're being asked to find a limit, notice if you tried to plug the -9 in directly, you're going to end up getting 0 over 0, which of course does not exist. And so what we try instead is we try to actually factor to see if we can get some factors to cancel, and then use the method of plugging in whatever value we're trying to find the limit. Okay, so on top, we have the factor x plus 9. On bottom, I'm going to first try to factor out a 9, and that's going to leave me with an x squared minus an 81. And then if I factor again, so we still have the x plus 9 on top, and we still have the 9, and then x squared minus 81, that's a difference of 2 squares, so it factors as x plus 9 times x minus 9. And so what we notice happens in this case is that your x plus 9 factors cancel. Now that does mean that we are left with a factor of 1 on top. So at this point we're looking at the limit as x approaches -9, and we have the function 1 over 9 times x minus 9. And so now if we actually plug in our value, which is the -9, we have a 1 over 9 times -9 minus 9. So that is just a 1 over 9 times a -18. And so that's going to leave us with a 1 over a -162. And it doesn't matter whether you put the negative out in front or on the bottom. That still means the same there. Okay, so on this next one, again, we will, if you tried plugging in 2, notice you're going to get, on top, you're going to get 4 minus 4 is 0. On bottom, you're going to get 4 minus 10, which would be -6, plus 6 is 0. So again, 0 divided by 0 does not exist. And so in that case, we will try to factor. So the top is a difference of squares. So that means on the top, we're going to have factors of x plus 2 times x minus 2. And then on bottom, if we factor x squared minus 5x plus 6, we're going to get factors of x minus 3 times x minus 2. And so once again, we'll cancel the common factors. And then at this point, we can actually plug in the 2. So we're going to have a 2 plus 2 on top and a 2 minus 3 on bottom. So that's going to be a limit of 4 over -1, or simply -4. Okay. Now, on this last one, this is going to take a little bit of work because this actually is the difference quotient. We're doing limits with the difference quotient, so we're getting ready to move into something called derivatives, and a derivative is based on a limit as some value h approaches 0. So for right now, we're just going to be focused on the algebraic part of this. So the first thing I'm going to do is I'm going to find the f of 10 plus h. And so this is my function over here. So basically everywhere I see an x, I'm going to be plugging in this value 10 plus h. So I've got a -2 times 10 plus h squared plus a 4 times 10 plus h, and then plus a 9. Now feel free to pause the video if you need to. I'm just going to work through the algebraic part of this, so pause it, or if you need to, just to kind of focus on where I'm getting things from. So 10 plus h squared, remember that's going to mean 10 plus h times 10 plus h. So I'm going to go ahead and write it out like that, just to make sure there that I don't make any errors when I'm trying to FOIL it. I'm going to leave the -2 out in front for just a minute. So 10 times 10 would be 100. 10 times h, and then another 10 times h, and then an h squared. And then I'll come back and I'll do all my distributing at the same time. Okay, so now with my negative 2, I get negative 200. That's minus a 20h, minus another 20h, and then minus a 2h squared. And then when I distribute the 4, I'm getting plus a 40, plus a 4h, plus a 9. So now I'm going to combine my like terms, pull the highest power to the front. So I've got a negative 2h squared. And if I look at my h's, this is negative 20 plus another negative 20 is negative 40. But then plus 4h would leave me with a negative 36h. And then my constant's negative 200 plus 40 would be negative 160. And then plus a 9 is going to leave me with a negative 151. Now, that's just the first part of it. So then I'm going to do the next part, which is the f of 10. So if I plug 10 in, I've got negative 2 times 10 squared plus 4 times 10 plus 9. So that would be negative 2 times 100 plus a 40 plus 9. So that would be negative 200 plus 49, and so that would leave me with a negative 151. So now if I go back to the original problem, I'm being asked to find the limit as h approaches 0 of the f of 10 plus h, so that was this answer here. So negative 2h squared minus 36h minus 151. And then the original problem said to subtract, so minus the f of 10, which is a negative 151, and then divide by h. So as you can see here, what's going to happen when you subtract a negative, this actually becomes plus a positive, so those are going to zero out. And then I've got a h on top. Both terms have a h, so I'm going to factor it out, which leaves me with negative 2h minus the 36 over h. So those h's cancel. And so now finally, the limit as h approaches 0, I can just plug in the 0 for my h. So negative 2 times 0 is 0, and 0 minus 36 would leave me with a value of negative 36.